Hello everyone, myself Himani Sharma from RPIIT campus. In today's class, I discuss about the advantages of the gravimetric analysis. Accurate and the precise gravimetric analysis is potentially more accurate and more precise than the volumetric analysis. Possible sources of errors can be checked. Gravimetric analysis avoided the problem with the temperature fluctuations, calibration error, and the other problems associated with the volumetric analysis. It is the absolute method relatively inexpensive disadvantages, but there are the potential problems with the gravimetric analysis that must be avoided to get the good results. Proper lab technique is critical, careful and the time consuming. Scrupulously clean glasswares, very accurate weighing and the co-precipitations. Next, the properties of the precipitate. The precipitate should be of the insoluble and that no significant loss occurs during the filtration and washing. Physical nature of the precipitate should such that it can be easily separated by the filtration, and the precipitate should be stable to the atmospheric conditions, and the precipitate must be convertible to the pure compound of a definite composition either by ignitions or by the simple chemical operations such as evaporations, and have the larger crystal easier to filter. Large the crystal be free of the contaminants. Next, the particle size and filtrability of the precipitates. Precipitate made up of the large particles are generally desirable in the gravimetric work because large particles are easily to filter and wash free of the impurity. In addition, such precipitates are usually pure, and then are the precipitates made up of the fine particles. Three types of precipitates are produced: crystallines, fluidy, and the gelatinous, etc. Process of the precipitations. It is the most important step in the gravimetric analysis. Involve the both physical and chemical processes. The physical processes consist of the three steps. First is the supersaturation. The solution phase contain more dissolved salt than at the equilibrium, and the driving force will be of the systems to be approved. Equilibrium, saturation, nucleation. Initial phase of the precipitation, the minute number of the particles will gather together and to form a nucleus of the particle or the precipitate. Solid phase, higher degree of the supersaturation, the greater rate of the nucleation. Nucleation involves the formation of ion pair and the finally a group of ions formed. It is of the two types, spontaneous and the induced. Crystals growth, particle enlargement process. Nucleus will grow by the deposition of particles precipitates onto the nucleus and forming a crystals of a specific geometrical shape, involving the two-step diffusions of ion in the surface of the nucleus and depositions on the surface. Precipitation process. Von Wiemarm discovered the particle size of the precipitate is the inversely proportional to the lattice supersaturation of the solution during the precipitation process. The von Wieman ratio, the lower the better. Von Wieman ratio is the Q is minus S upon S, a measure of the relative supersaturation or saturation ratio. If high, get excessive nucleation, lots of small particles and crystals, large surface area. If the low, get larger, fewer crystals, small surface area. As the solubility of the precipitate at equilibrium, keep it high with the high temperature adjusting pH. Q is the concentration of reagent before the precipitations. Keep it the low, and by using the dilute solution and stir mixture well and add the reactant slowly. Can lower the S later by cooling the mixture after crystals have formed. In today's class, I discuss about the following process of the precipitation.